Hi, this is Professor Merrill Lichty. In this video, we're going to look at the chi-square test and its use to check for independence between multiple categorical variables. Here's an example from the text that will help us understand what we're doing here. Imagine that there's a hotel chain that has three different hotels: the Golden Palm, the Palm Royale, and the Palm Princess. And when people stay at this hotel, they're asked whether they would return or not. And of those that say they would not return to the hotel, they're asked why they wouldn't return. And the options are either price, location, something to do with the room, or other. And in this example, we have 187 hotel guests that were asked whether they would return, and they said no. And they were asked further why they wouldn't return. This type of table is called either a two-way table or a cross-tabulation table, or you might even see it called a contingency table. What I'm interested in here is trying to understand why people say they don't want to return to a hotel, and the basic research question is going to be whether that's independent of the hotel that they stayed at. So the alternative hypothesis will say that they are related, they are dependent. The null hypothesis says that the reason for not returning and the hotel visited are independent of each other. We're going to use an alpha equals 5% significance level for this. We're going to use the chi-square test here, and it will have the same basic setup as what we did with the test for equal proportions. And that is to say, we want to know what the expected frequency is for each of the cells if the null hypothesis is true. And then we will compare that with what we have observed. So in order to find the cell frequencies, we're going to need to use some probability theory. So let's focus on the highlighted cell, location, and Palm Royale Hotel. And if we were to randomly select one of the hotel guests and say what's the probability that they won't return due to the location, all we'd have to do is go over here and say we got 60 that said they wouldn't return due to location. Divide that by 187. Similarly, we could find the probability that someone randomly selected stayed at the Palm Royale, and that's going to be 33 divided by 187. So there's 33 here, divide that by 187. So if the null hypothesis is true and these variables are independent of each other, then we should be able to find the probability that a guest stayed at the Palm Royale and won't return due to location by simply multiplying the probabilities for each of those individual events that we just found. So we have 60 over 187 times 33 over 187, which is about 5.5%, or 0.05662. To get the expected number, all we have to do is multiply that number by 187, and that gives us the 10.59. Let's look in a little more detail at this calculation that we just did to find the expected frequency. We took 60 over 187 times 33 over 187, and then multiplied that by 187. Now, two of these 187s are going to cancel, and that leaves us with 60 times 33 over 187. And just like we did with the chi-square test for proportions, we have the formula row total times column total divided by the grand total. And this is what we're going to use whenever we have a chi-square test that we're doing. So we fill in the rest of the cells in this table, and we have in parentheses the expected values. And now we need the degrees of freedom. And for chi-square tests for independence, the degrees of freedom are going to be the number of rows minus 1 times the number of columns minus 1. So in this case, we have 4 rows, so 4 minus 1 is 3. And we have 3 columns, so 3 minus 1 is 2. Multiply those together, and we get 6 degrees of freedom, which, similarly to what we did with the proportions test, says we can fill in any 6 of the cells in the table, and that determines what the rest of the cells are going to be. Now that we have the table filled in, we can come up with our chi-square test statistic. And we're going to do exactly the same thing we did with the test for proportions, where we take the observed minus the expected frequency, square that, divide it by the expected frequency, and add all those things up for all of the cells. And if the null hypothesis is true, these things are going to be close to each other, and the difference will be small, so when we square it we'll have something small. We add all that up, we'll have something small. That will be evidence in favor of the null hypothesis. So to get that value, we're going to take, starting with the first cell, 23 minus 31.53, square that difference, divide by 31.53. We're going to do that for all of the cells, and we get a test statistic of 27.41. By way of reminder, the null hypothesis is that the hotel visited is independent of the reason for not returning. Our degrees of freedom are 6, and we have an alpha level of 5%. So doing a hypothesis test and using this information says we need a critical value. We can look to Minitab or could use Excel for this. For Minitab, we're told that the point that has 5% of the area to the right of it on a chi-square distribution with 6 degrees of freedom is 12.59. So our rejection region is going to be anything bigger than 12.59. And our test statistic was 27.41, which says we should reject the null hypothesis and conclude that there is a relationship between the hotel visited and the reason for not returning. Here are the Minitab results for this chi-square test. You can see that the chi-square test statistic is given down here in the bottom, 27.41. Degrees of freedom are 6, and the p-value is 0. Now that we've rejected the null hypothesis, we want to know what the nature of the relationship is between these two variables, and if there's anything that we can do to learn from that. We're not able to use the M procedure as we did with the test for proportions because this data is not quite the same. We need 2 rows in the table for that to happen. So we're not going to use any procedure. We're going to look at the test statistic that we observed, in this case 27.41, and try and figure out why it's so large. And that should help us to understand what's going on here. In the Minitab output, we see the last number here, 2.30, 1.96, 7.54. That is the contribution that each cell makes to the overall chi-square statistic. So if we look for the biggest ones of these things, 7.54 for the Palm Princess and price, 8.199 for Palm Princess and location, and 4.1 for the Golden Palm and location. We see that those things add up to almost 20, which is most of the chi-square statistic. The biggest contributor to the chi-square value is 8.199 for Palm Princess location. And if these things are independent of each other, we would expect to see 21.18. People say they're not coming back, but we only saw 8, which is much less than we expected. So that says the location for the Palm Princess is probably fine. On the other hand, if we look at the price at Palm Princess, we expect about 24, but we observed 37. So that says that more than we expected are not coming back because of the price. And so despite having a good location, people are not happy about having to pay so much to stay at this hotel. So the manager might want to consider reducing the price for the Palm Princess. The other contributor is not quite as significant as the others, but basically we're looking at the Golden Palm and location. We expected 28 and we observed 39. So this says that people are not real happy about the location. Now there's not much the management can do about the location, but there are other things maybe they could do to make it more attractive, reduce the cost or other things like that. The point that you should take away from this is that if we look at the major contributions made to the overall chi-square test, we can get a pretty good story about what's going on in the relationship between these variables. Let's summarize what it is we've done in this unit. We introduced hypothesis testing with continuous data. We focused on 1 and 2 sample Z and T tests. Alternatively, we can use a chi-squared test to deal with categorical data. Just like we did with one-way analysis of variance when we tested for differences in population means, we can use a chi-square test to test for differences in proportions. And we have a procedure, the M procedure, for testing the multiple comparison. When we find a difference in the proportions, We can also use chi-square tests to determine whether two categorical variables are dependent or not.